All right, Algebra 2 students. Good thing we have no school today, am I right? Hey, every once in a while it's just good to have a snow day. While we were here, I wanted to throw out a little just suggestion to you. If you haven't seen the Nickelodeon teen film / romance Snow Day, you absolutely need to go watch it. Ignore the IMDb and Rotten Tomatoes ratings. It's one of the best bad movies ever. You know how there are movies that are good bad movies, how they're bad but they're good. Well, go watch it. It's a great movie. Wherever you need to find it, wherever you need to stream it, go watch it. What we're going to do here is we're just going to do a quick lesson. It's not even going to really be a lesson. I'm just going to walk you through a couple of things, and I'm going to put these notes on Haiku, and it's only 4 slides, and what I want you to do is I just want you to go through these slides and do them. It's basically just a practice problems. I'm going to flip through them really quickly. Okay, and we're going to go through some of these together, but really what I want you to do is just kind of work on these on your own. Okay, so I'll walk you through this lesson really quickly. It'll be less than 10 minutes. I'll put the notes on Haiku, on PowerSchool, and then you can just complete the notes and be ready on Thursday with these notes completed. All right, so as I mentioned the other day, why we learn to factor is so that we can solve these equations. That's the only reason that we do this. Okay, so solving these equations is very much the same process as factoring, but now we will add one more step to get to where we wanted to get to all along, which was solving. So if you remember, a polynomial equation in general looks like ax squared plus bx plus c equals 0. All right, that's the generic form. To solve one of these, you need to move all of the terms to one side. Okay, in other words, I need to add or subtract all of the terms to get them to one side so that one side of my equation is equal to 0. Okay, so in this case right here in the general form, you can see we already have that. We already have one of our sides equal to 0. Hang on just 1 second, students. My dog is barking at me outside. Let me go let her in. And she didn't want to be let in, of course. So if you move everything to one side, then one side of your equation will be equal to 0. So once you have everything moved over to one side, then what we will do is we'll factor. And then, lastly, we will solve after we have factored. All right, so when we do this step, our polynomial equation will look something like this. All right, where we'll have our two things that we would multiply together to get back to here. And then once we have this, we will solve. What is a root? You may have heard that before, you may have not. What is a root? Also known as a zero or a solution. Well, all of these things are values that would make an equation equal to 0. Values that would make an equation equal to 0. Okay, and while that might not seem very useful, it's extremely useful. Understanding what values I could plug in for x right here that would make this whole thing equal to 0 is a very, very helpful thing, both in terms of our understanding for math, but also in terms of our understanding of physics, our understanding of things like architecture, our understanding of things like chemistry and biology. So what we're going to do is we're just going to walk through these steps with a few examples. Okay, so here, solve, identify double roots. Okay, well, here we go. This first example, is everything equal to 0? Yes. Everything is already equal to 0. Is it factored? Yes, it's already factored. So the first two steps we have already done. Okay, so now what we need to do is solve. How are we going to solve this? Well, now that we have this factored, all that we have to do is think about this. If what was inside of this parentheses, somehow became 0, like let's just say we just inserted 0 into here, then wouldn't that make this whole equation 0? Because what we'd be doing is we'd be multiplying 0 times x plus 4 squared, and anything multiplied by 0 is 0. So I could find a solution, a root, or a 0 if I set this, what's in this individual parentheses, equal to 0, and then solve. If I can figure out what I could plug in for x to make this, what's in this parentheses, equal to 0, then it would make this whole equation 0. So how would we solve this? Well, we'd have to add 1 to both sides, and then we'd have 2x equals 1. And then these are connected by multiplication, so I'd have to divide both sides by 2. And I would get that x is equal to 1/2. Okay, so x equal to 1/2 is a root of this equation. Okay, that would make this whole equation 0. But that's not the only one, because what we have over here is we have another expression. And if I can make this equal to 0, then similarly, if I can make what's in this parentheses equal to 0, then it would also make this entire equation 0. So clearly you could see that x, once we subtracted 4 over, would be -4. And since this is squared, remember, something being squared is the same as me writing it like this. X minus 4 squared, whoa. X minus 4 squared is the same as x minus 4 times x minus 4. So since it occurs twice, we call this since it occurs twice, since that is 2, we call this a double root. That right there is a double root. Okay? So the two values that would make this polynomial equation equal to 0 are x equals 1/2 and x equals -4, and x equals -4 is a double root. Now let's go through this one. First thing we need to do is set everything equal to 0. Is everything equal to 0? No, but what I could do to make this equal to 0 is just subtract this 18 over. So when I do that, I would get y squared plus 7y. I'm subtracting, so that would be minus 18 equals 0. All right, so I've done the first step. Now I need to factor. Okay, so I'm working with the factors of -18 to add to positive 7. I know this is going to be y and y. All right, the first two factors of -18 that are the closest are -6 and 3. -6 and 3. Those do multiply to -18, but they add to -3, which is not positive 7, so these are not correct. If I switch the signs, these are still not correct. This only adds to positive 3. 6 minus 3 is positive 3, which is not 7, so I need to choose two new factors. The next closest factors of 18 that I can think of are 9 and 2. Now, one of them has to be negative, one of them has to be positive in order for this to be -18. And if I want this positive, then I want the bigger number to be positive. So look at that. Here we go. Positive 9, -2. That does give me 7. So I know, which is this middle term, so I know these are right. So this is going to be y plus 9, y minus 2, and so now I need to solve. So what I need to do, remember, when I'm solving is I'm finding out what value of y would make this individual parentheses equal to 0 and this individual parentheses to 0. So I need to set each of what I have in the parentheses equal to 0 and solve both of them. And you can see really easily that this is going to be y equals -9 and y equals 2. They both only occur once, so neither of them are a double root. So when we factor, this is why we're factoring. We get to this step so that we can identify what values we could plug in to this equation that would make it equal to 0, and here would be -9 and 2. So what you have is you have 2 more slides that are more practice problems, and I want you to do them on your own and bring them to class on Thursday ready to be talked about. We will talk about these. These are obviously a little bit more difficult. If you need some help, you can use Wolfram Alpha. But do these ones, and then we'll talk about them, and then we'll do some more practice problems, and then we'll do an assignment together that will be for a grade. All right? Thanks, guys, and happy snow day.